Hi everyone and welcome to this new edition of the Wasp development log. In this edition I want to show you 3 new features that have been added in Wasp 04005 which should allow you to highly improve your workflow when using Wasp. So these 3 features are, first of all, the possibility of using a part catalog not only as a limited reserve of parts but also as a proportional, meaning that the number of parts will be varying within the aggregation and will be more than the one listed in the catalog itself, but will retain the proportions between them. The second feature that I want to demonstrate is a brand new local constraint, which is the Adjacency and Exclusion constraint. And this is a constraint that is built on top of the support constraint, but which now allows you to identify specific areas of each part which are required or are not allowed to be in contact with another part. And lastly, we are going to see the current work in progress version of aggregation graph component that would allow you to extract the full graph of the aggregation after generating it. So let's get started. If you download the file that you might find in the description box of this video, you'll find an aggregation which contains 3 parts. So it contains a box, a stick, and an hexagonal prism extracted with their own connections identified. And this is connected to a rule grammar, so a rule generator which uses a specific rule grammar. If you don't know how rule grammars work, you might check the rule grammar video. I think it's tutorial number 5 in the Wasp 101 tutorial series. And we then run a stochastic aggregation and we end up with something. So we need an aggregation that follows these rules. Now I'm gonna hide the base parts just not to have them in the way. Now the first thing that I wanted to demonstrate is the brand new added possibility of using a part catalog which uses which allows you to set limits or proportions to the parts. So if I take this catalog and connect it to the cat input and reset this one, you will see that I set that I would like to have 30 parts of the stick of the box type, 5 parts of the stick type, and 18 parts of the hexagon type. And what happens when I reset is that I actually get that, and since the input of the limited catalog is set to true, the aggregation will stop when it has exhausted the number of parts that are in the catalog. Now, one extra little feature that you have now is that you can actually now remove some parts and then grow them again, and this will still keep the correct amounts of the catalog. That was not working before. But so this will actually stop whenever it's created a number of parts that matches the total sum of what's in the catalog. If we instead would want to create an aggregation that has this proportions in between the parts, but can actually grow beyond that, we can simply set the limited input of the catalog to false. And if now I reset my aggregation, you see that I can keep growing the aggregation larger. But what's going to happen is that this is going to try as much as possible to keep the correct proportions between the parts that are specified by these amounts here, but we'll keep growing the aggregation. So this will not be taken as fixed quantities anymore, but just as a proportion between the different parts. So this was the first feature that I wanted to demonstrate. Now, the second feature that I talked about are adjacency and exclusion rules. So I'm gonna create a little bit less parts. So you see that, for example, in my grammar, bridges are not allowed to connect to each other. So the stick components are not allowed to connect to each other because there is no rule grammar that allows them to connect. However, it happens sometimes that sticks end up touching each other just because that's geometrically that might happen. So we have the possibility of using what's called an exclusion rule to make sure that that's not there anymore. So For example, in this case, what I've done is on my stick part, wait, I'm gonna maybe show it to you in Rhino. So on my stick part, I defined 4 lines that pass through the part and are on the sides. And I can define those lines as exclusion rules, meaning that I can say whenever one of these lines intersects another element when it's placed, it's not going to allow that to place. But not only that, but also we can also specify that that has to be a part of a certain type. So in this case, I have 4 lines. And what I said is that each of those 4 lines is not allowed to intersect with a part of the type stick. So I write stick 4 times, which is 1 for each part, for each line here. And then I set this one as false. And when I set it to false, I'm saying that this is an exclusion rule. So this component allows you to do 2 things, to set exclusion rules and adjacency rules. So when it's set to true, and we're going to see it here further, it's going to require that part to be close to that. And when it's set to false, it's going to force that part not to be close to that. So if I now take my adjacency, my exclusion rule here, and I drag it up, and I drag it and connect it to the adjacency and exclusion rule on my part, and I make sure that the mode of the aggregation is set to 1, meaning that I'm using local constraints. If I now reset, you see that the result that I get is that there are no bridges that are touching each other, and that's because I set this exclusion rule. Now, what I can do with the sticks is I can also force them not to be flying, but to have them there. So now you might know how to do that with supports. The other way of doing it now is, and it's probably going to be replacing the support component entirely in a further version, is you can set an adjacency rule. So in this case, I'm saying I have, again on my part, I have 2 lines, which are here, and I added them to an adjacency constraint, and I'm saying that these parts have to both be adjacent to a part of type box, which means that this stick cannot fly in space. If now, instead of adding just my exclusion constraint, I'm going to add also my adjacency constraint, and I'm now going to reset, you see that I have my sticks that do not touch each other, and not only they do not touch each other, but they're also always supported by 2 boxes, and that's because we use that. Now, you can use adjacency and exclusion constraints also as part independent, meaning that if you don't set the part name input, it's going to work the same way as a support works. So it's going to check all the parts. So in this case, I'm setting my my hexagon here to have an adjacency constraint, and we can see it in Rhino, which is this line at the bottom, which you can see there. And so what I'm fundamentally saying is that this hexagon is not allowed to fly in space, but it always has to be supported underneath it. So if now I look at my aggregation, you might see that, okay, in this case, it's not the case, but if I'm going to reset a couple of times, you'll see that I'm going to have flying hexagons. If I'm now going to add my adjacency constraint to the AC input of the hexa part, and I'm going to reset it, you'll see now that all my hexagons are somewhat supported by a part underneath it. And that's going to stay the same no matter how many parts I add. Of course, setting constraints will create some extra limitations, and so it might be that your part catalog, if it's set to proportional, it's not going to be able to match exactly the distributions you're given, and that's because it's very hard to place certain parts because of the constraints. But if you would set this to limited, you're going to actually make sure that whatever you're building always matches the number of parts you have. And so in this case, you see that I can add more or less bridges, more or less sticks, more or less of those, and those match all the constraints, and as well as so you see sometimes it's not gonna work, like in the case of setting so many constraints on the sticks, there is just not enough space to place all the sticks I wanted. So if I would now increase this and reset, now it's gonna be instead able to place some more sticks, but still it's not able to place all the 18 I gave. So you see, you have to manage a little bit when you start using constraints and catalogs, which still work as some sort of constraints. You're gonna of course have some issues. However, this comes at the advantage of having various points in the aggregation now when you can start controlling what's the final result. If, for example, now I would notice that it's not possible to place all the sticks, I could, for example, go back and remove my stick at the exclusion rule, and if now I reset, you see that it's going to be able to place all the sticks I wanted. So this is it for new aggregation methodologies that you might find in the latest Wasp component. The last component that you will find is something that is more there to analyze an aggregation, or also to further process it, for example, create fabrication data, or define assembly assembly sequences, and so on. So this component is still experimental, and I'm not done with it. So actually, this is the only input that works. The other ones, no, this and the last one as well, the other ones are still not working. But so what this component does is it takes an aggregation from the aggregation, from one of the aggregation algorithm you might want to use. And what it's going to do, it's going to be able to output a graph containing node and edges on how parts are connected to each other. And you'll see that it's able to detect connections that also happen geometrically, even though they're not defined by directly the aggregation. And so what's going to output is a graph object for which I'm going to provide further on more algorithms and more components to work with. Then it outputs a list of nodes and a list of edges. And then for each edge, you have the start ID and the end ID of each of the part which is connected to, as well as the connection through which these two parts are connected. And so this might be really useful, for example, to create joinery details, or to kind of process your aggregation in a variety of ways. One little extra thing, you have here the possibility of, by default, the edges and the nodes and the edges are flattened, so you will see we'll just get a list of edges. If you set this to false, nothing works. Okay, never mind. It's supposed to work, but I'm gonna have to fix that. So this is it for this development log. I hope you will enjoy the new features. You can find them in the new Wasp 0.4.005 on GitHub. Most of these features are still new and experimental, and I haven't really tested them, neither in a teaching nor in a research context. So I'm very much looking forward to hear your feedback and whether you would want to see them implemented in different ways, or what you could see them used for. So thanks for watching, and see you in the next episode.